if we
meeting as well that we can also schedule through the mailing list, right?
That's actually a great point. Yeah, because I think both of those are important points to continue talking about. Okay. Sounds great. Sounds great. So, yeah, so expect everyone, you can expect mails on both of these things. So keep an eye.
Wrapping our kind of work somehow.
Okay. Yes, shall I say a few words about the RepRap project, and then people can ask any questions that you'd like to ask. I'm a retired engineer. I used to be an academic at the University of Bath, and around the turn of this century, that university was given just under £500,000 to spend on equipment, and I amazingly was told to go away and spend it. So the university trusted me with this money, which came to me as a bit of a surprise. But I decided to buy a couple of 3D printers. The university had none at the time. One of them cost about £250,000 and the other one cost the change. And I'd known about this technology for 25 years before that point, but I'd never used it because I'd been engaged in research in other areas. And these machines arrived and we started using them. And it suddenly became apparent to me that they were quite extraordinary in a respect which I'll get to in a couple of moments. But going back even further in time, I've always been interested in the idea of self-reproducing machines right since childhood. And I had an academic interest in that area, though I'd not done research in it. I kept up to date with people making, for example, robots that assemble themselves and that sort of thing. Anyway, once we got these 3D printers, it was immediately apparent to me that for the first time, humanity had a technology that stood a serious chance of being able to make a copy of itself. And so I combined that with my interest in self-reproducing machines and decided to set up a project to make a 3D printer that would print more copies of itself. And this seemed to me, perhaps immodestly, like a fairly powerful idea. So I thought I was at least obliged to tell people that I was going to do it. And I gave that job to the university's publicity department. They put out a press release about the project that I was starting. And as a result of that, quite a few big media companies got hold of this and started writing stories about it. Indeed, Nico's just mentioned one of those stories that was written about it by her. People also like the New York Times, BBC, various newspapers in India, all around the world. And as a result of this publicity, it generated a great deal of interest among the general public. And as I say, this seemed to me like a fairly powerful idea. And of course, one of the things when you've got a powerful technology is that a good way to make bad things happen is if it's concentrated in the hands of a few people, because of course that generates even more inequality than the world is experiencing at the moment. Now, all right, I would be one of those few people as it was my project and it stood a chance of making me an enormous sum of money, and that was clearly extremely good. But equally, I could see that it wasn't necessarily good for everybody, and I was perfectly comfortable. And so I decided to open source the project as a means of making sure that everybody had access to it and that nobody could have any exclusive rights in it. Literally 2 minutes after I decided to do that, I realized that if you've got a self-copying machine, you have to make it open source anyway, because if you try and protect it with patents, or you try and copyright the designs, or any of the other ways that one might have of stopping people from using what you've created, what you're basically saying to the world is, I want to spend the rest of my life in court trying to stop people from doing with my idea the one thing it was intended to do, which is namely to copy itself. So I open sourced it from initially sort of rather pompous high moral principle, but then from an actual game theoretic inevitability secondly, if you've got something that copies itself, it's crazy to try to protect it. Anyway, all this newspaper publicity brought on board a number of people who volunteered to do some work on the project all around the world. And so we started off and we started doing designs and we started putting together electronics and software and so on and gradually building the machine. And after 3 years, in about 2008, we had the first machine that was capable of making a copy of all the plastic parts that went into that machine. It couldn't copy the metal bits and it couldn't copy some of the electronics, but it could copy all the plastic bits. And if you added it all up, that was about 60% of the whole machine that it could make for itself. The other decision we made is that all the other bits, the bits that it couldn't make, should be very widely available. So you could buy most of them, in fact, in an ordinary hardware shop, and one or two that we had to buy online, but they were available all over the world just from ordinary engineering suppliers. And so we had a machine that could copy itself and that anybody could copy because the design was completely open source, and that they could buy all the bits that it didn't make for itself very easily. Now, I mentioned the sum of money that the university had been given to buy these initial machines, which led me to have the idea of making a self-copying 3D printer. And the cheaper of the two machines that I bought cost about £60,000. And by the time we got the working machine going, we got that cost down to under £600. So we'd made a reduction in the cost of these machines of a factor of 100 in 3 years. Once all this information was out there, various companies started latching onto it and making the machines according to our designs and also modifying our designs and selling those. And some of those companies subsequently have grown quite big, and pretty much every 3D printer that you see working in the world is a descendant of that initial design. But those descendants, in a sort of Darwinian way, have diverged because, of course, as it's an open source design, people can download it and they can improve it. And what's more, they can use their existing machine to print improvements and update it and upgrade it, and the license obliges them then to put those improvements back into the public domain. Having said that, not everybody does so, but enough people do that the designs have both diverged and improved over the years. And now most of the machines that are available for prices around £500 to £1,000 can produce much better quality output than those initial commercial machines I bought back 20 years ago for £50,000 or £60,000. So the project's out in the world. There are lots of companies making versions of it and 3D printers based on it. One of them is in the Czech Republic, a company called Prusa Research, which is run by a bloke called Joe Prusa. I think that is actually the biggest 3D printer company in terms of numbers of machines shipped. And basically he has an enormous warehouse full of these machines, printing copies of themselves, and they put those copies in cardboard boxes, send them out the door on pallets all over the world. But of course, it doesn't have to be a large commercial exercise if you want to make one of these machines. If you have a friend who's got one and you have the technical ability, you can get your friend to print you a set of parts for a new copy of the machine, and then you can build one for yourself. And many people have done that as well. So we've got this machine, it's out there. As it were, my work here is done. Though I still do some work on 3D printing, I tend to work nowadays more on applications of it and building robots using these 3D printers. And lots of people have taken the products of these machines in all sorts of different directions. There's a group, for example, who are using them to make horticultural robots so that they can till areas of land with a machine that's solar charged. And you just release it and it has a little computer on board, wanders about picking up weeds and making sure that the plants you want to stay there are growing happily and make sure they're watered and so on. And so and you can imagine a circumstance where you have a large number of those robots tending quite a large area of land correspondingly. The machine's been used to solve the housing shortage, which may come as a surprise to you. Perhaps a bit of elaboration is required about that. One of the people who had a RepRap machine was also a scuba diver, And so he printed a whole load of plastic artificial seashells. And he went out into the bay and tipped them over the side of his boat. And then a week later, he went back and dived in the same area, and he discovered that hundreds of hermit crabs had taken up residence in these shells. So when I said that it solved the housing shortage, unfortunately, I didn't mean for the human species, but for another species entirely. And nowadays, the machines are mature. They work in multicolors. They work in multiple materials, not just plastics. You can get machines that work in ceramics. You can get machines that work with low temperature melting point metals. You can get metals that melt at temperatures down to 50 or 60 degrees C if you make the right alloy. And all of those machines are out there jostling in the world. And because most of the technology is open source, it's being continually improved by people who just think of a better idea. And the machines, as I say, diverge and improve as a consequence. So that's a brief history of the project. And I really can elaborate on any aspects of that. In particular, I haven't said anything very technical about it, but if anyone's got technical questions, of course, I'll be happy to answer those. And in particular, perhaps what I haven't said very much about is the fact that I said that the technology was the first one we had, which stood a realistic chance of making a copy of itself. There are mathematical reasons to do with for that capability, which are to do with the fact that the computer controlling machine has a comparatively easy problem compared to almost every other way that human beings make things. Because the machine is very easy to control, it's correspondingly very versatile in everything that it can manufacture. Basically, 3D printing can make more different shapes than any other production technology that we have. So anyway, of late, lots of private individuals with these machines have unsurprisingly turned them to printing face masks for people working in the health service because as you recall, there was a considerable shortage of PPE at the beginning of the coronavirus epidemic. And so suddenly we had thousands of people all printing face masks. Now, each person perhaps printed 5 or 6 face masks a day, which is hardly any. But when you've got many thousands of people doing that in their spare bedrooms, it adds up to quite a lot. And that response was faster than conventional industry could respond. When conventional industry kicked in a month or so later, they could produce many more, but they couldn't do it as quickly as all those private individuals coordinated over the internet, working, as it were, on their own, but as a collaborative. And that's one example of the sort of thing that this technology allows when you've got a large number of these machines in private hands. Anyway, that's an overview of how it came about and how it was developed and where it is now. So I'd be, as I say, happy to answer anybody's questions.
Thanks so much, Adrian. Nika had a question.
Yeah, maybe I can have a first question. Because, yeah, I'm just so happy to talk to you. So my first question will be about actually a political manifesto. That's also really, really surprised me when I find out about you and about RepRap, because it's not only looks like a 15 years ago last total science fiction claim, but also you were quoting Marx and Communist Manifesto on a page of the university. That was like, wow.
Well, yes, of course. I mean, Marx, of course, was concerned almost more than anything else with the means of production. Now, it was the case in the 19th century and for pretty much the whole of the 20th century that the means of production was owned in some cases by governments, but largely by companies which grew big if they could make more and more and sell more and more. And they made money for their shareholders and so on. But of course, there's an exception to that, which is agriculture. agriculture is the only human industry which is based on things that copy themselves, well, apart from rat now. And one of the interesting things when you look at very big companies is that they can be very, very big indeed. Companies like Exxon and Toyota and so on are enormous enterprises. And yet the biggest industry in the world is the production of food. And there's a surprising thing when you look at the food production industry. There are, of course, big agricultural companies, companies like Monsanto and so on, but they're nowhere near as big as the biggest companies in other areas of human endeavor. And it seems surprising to me that the biggest industry should not also give rise to the biggest companies. And I hypothesize, and it's no more than a hypothesis, I don't have any evidence for this, that the reason why agriculture doesn't gather together to form bigger and bigger companies is because, as I say, it's entirely run by people who are concerned with things that copy themselves. The whole of agriculture is based on self-copying, whether it's wheat or it's cows or chickens or whatever. And the very nature of self-copying is that it makes it so easy to make things and so easy to distribute things to other people who then have the capacity to make things as well, that very ease of people getting involved, at least at the smaller scales, prevents too much accumulation and unification to form large or possibly even monopolistic whole. So if we've got an open source manufacturing machine and it's capable of copying itself, we've got the means of production and anybody can have access to it, and anybody who has access to it can give access to it to anybody else whom they choose. And so we've got the distribution of the means of production to the population right down to the level of individuals in principle. And it's something that's uninterruptible. And what's more, we haven't had to have a bloody revolution in order to achieve it. So I don't know how far along that road we've progressed, but it's certainly the case that there are a lot of these machines out there, and a lot of people who have them are using them to make machines for their friends as well. And the capabilities of the machines are growing and growing. In a few years' time, they'll be making electric motors, for example, as well as just plastic objects or ceramic objects. So we've got this idea of the means of production being given to the people, but without the people actually having to use force to acquire them.
So actually, if I can speak, like a comment, maybe to reinforce that, is one of the things Monsanto does is it tries to prevent its product from being reproducible by copywriting the genetic code of the plants. So it's maybe trying to monopolize by trying to make it exactly not what it is, what you're saying. So.
Yes, that's what they do, indeed. And there are all sorts of examples of this. Let me take something that's slightly closer to 3D printing, which is two-dimensional printing, the Hewlett-Packard printer that many of us have in our spare bedrooms attached to our computer. Of course, Hewlett-Packard are very concerned that they should be the only people to sell you ink to go in your printer. And before the RepRap machine came along, all the 3D printed companies used the same technique with the plastic that went into their machine. You had to buy their cartridges to go with their machine. Now, of course, RepRap completely undercut that model because anybody who has a 3D printer can use the 3D printer to print the cartridge, if you see what I mean. And so once you've got control over the technology, the idea of preventing people from having access to it who don't pay you starts to go out of the window, because people can circumvent all of these artificial restrictions that can be placed in exactly the same way as, you say, Monsanto patenting the genes that go into the plants that are resistant to glyphosate and all this sort of thing that they produce.
Adrian, can I ask you, where does the plastic itself actually come from? How dependent on the petrochemical industry is this technology?
Less than you might imagine. When we started, the principal plastic that was used was plastic called ABS, which is the stuff that Lego bricks are made from, and that's made from oil. However, one of the first people on the project, a guy called Vic Oliver from New Zealand, And he discovered that a comparatively new plastic called polylactic acid worked rather better in the machines than the ABS that the commercial companies were using. Now, there were two advantages to this. One is the obvious one, it works better. The second is that PLA is made from starch. So that doesn't come from oil at all. In fact, it's quite easy to make from starch for yourself. So there's one tricky step to it, which I'll come to in a moment. But if you can grow a starch crop, which is basically corn or potatoes or whatever, and you've got a few square meters of land, not only have you got a self-reproducing machine, you've got a self-reproducing supply of the raw materials that the machine consumes in order to manufacture items. I said that PLA is easy to make. It's essentially a fermentation process, rather like home brewing. But there is one tricky step, and only one, which is that at a certain stage you have to get one of the materials that you've made very, very dry indeed. And I don't just mean dry as in leave it in a dry room. I mean less than 10 parts per million of water. And in order to do that, you have to pass very dry air over it. And we did that in the university lab. But you can do it with technology that basically consists of plastic bags and fans and cardboard boxes and so on, if you're a little bit careful. So we've got a machine that copies itself, and we've got a supply of raw materials that isn't based on oil that also copies itself. However, comparatively few people, I have to admit, make their own plastic. And the reason for that is that an industry has grown up, which is supplying reels of plastic to people who run these machines. You can buy it on eBay, you can buy it on Amazon, you can buy it in some cases, in some cities, in actual stores on the high street. And at the moment, the effort of making your own plastic really doesn't quite beat the straightforward nature of getting your credit card out and spending a tenner on a big reel of the stuff.
I actually had one question from the chat, Adrian, which is, if you have a view of, how something like RepRap connects to what we're doing in the Museum of Care, or like how you...
I can rewind a bit. You broke up there. I apologize. I couldn't hear you.
No worries. We basically, I think there's one question in the chat around, how RepRap, in your opinion, might fit with what we are doing here, with Museum of Care. And if you've done similar collaborations with other groups like ours in the past.
We have, well, first of all, we've done things with conventional museums in the past in reproducing exhibits which were too delicate to go on public display. So one of the first things that the person I mentioned from New Zealand, Vic Oliver, did was to use his machine to reproduce some Maori artifacts that were in a museum in New Zealand. And they didn't want those artifacts on display because they're quite old and they would be damaged by light. And so what he did was to make some copies of them in the machine, and those were put on display instead of the original. Describing that. But in general, it's a technology that's incredibly versatile at making virtually anything. Now, it depends really what you want to achieve. Give me some examples of things which currently you want to do, which involve material objects, which would be difficult to do. Perhaps you can do.
I have one thing.
Yeah.
Like, can we make two things: clothes and a bean harvesting machine?
Clothes, yes. People make chainmail with this technology, which is interesting. Of course, it's not particularly discreet as clothing is concerned because you can see through chainmail by and large. But it's been used extensively in the fashion industry to make very interesting garments. There's something else you can do, which is that you can take an ordinary fabric, and if you put it in the machine, you can then print plastic onto that fabric, which allows you, for example, to take a garment and print panels all over it. And those panels could be thermally insulating. They could be protective if you wanted to make say a vest which you were going to use for riding horses, and when you fell off, you didn't want to break your ribs. So it allows you to do that sort of thing. And sorry, what was the second item you wanted to make? I beg your pardon.
Oh, bean harvesting machine. So
Oh.
yeah, last week someone was really keen on having a bean harvesting machine. I was like, how on earth are we going to get that? So, yeah.
Well, yes, the problem there comes down to, can you create a system? The problem there is basically software, not hardware. Can you make a camera which can tell the difference between a bean and a leaf? If you can do that with a image recognition system, then making a robot to pick them shouldn't be too difficult. I can tell you about a related project that I started but abandoned, and the reason I abandoned it was nothing to do with the fact that it wasn't possible. It was to do with the climate. I mean, the climate in this country and the fact that it's a bit cold. I thought that it might be a good idea to make a saffron harvesting robot, because saffron is the most expensive material you can buy for cookery, just about. And of course, the autumn crocus, which is where saffron comes from, has a pale purple flower, and the saffron itself is a dark, dark orange stamen against that purple, which is very easy for a camera to recognize the difference on. So it seemed to me that basically a robot with a pair of tweezers and a plastic bag could go along picking this stuff and putting it in the plastic bag. And I got some way towards realizing that, but then unfortunately, the thing that I was doing in parallel was to try and grow autumn crocuses in this country. But they don't like the climate, unfortunately, and so regrettably they all died out. I suspect it will work in somewhere like, I don't know, Iran or wherever, where they do currently grow saffron. And of course, the reason why saffron is so expensive is because it's so incredibly labor intensive to harvest it. And that is an ideal task for robots to take the backbreaking effort out of it. So beans we could probably do, I think, yes. Particularly if they're grown in rows in a fairly structured way so that the robot can move between the rows and so on.
Great. Any other questions?
I have a question too. Yeah.
Go for it, Sada.
Yeah, can we use a recycled paper instead of like plastics?
Not in a little bit. Let me talk about recycling in general, and then I'll come to the thing about paper specifically. The first thing is people use recycled plastic in these machines all the time. And one of the nice things you can do is you can use the machine to build a recycling machine. So people use the RepRap machine to make a plastic grinder, and you drop milk bottles into it, and it comes out as little ground up pieces of plastic. You can then feed them into a second machine, which extrudes that out as a long, thin filament, like a very fat fishing line, and that goes into the machine. So we've got recyclers, people make them themselves, and they produce feedstock from the machine from conventional plastic, including, of course, 3D printed objects that are no longer wanted. You can put those through the recycling system as well. And in fact, I made a pair of Charles sandals, one of the first things I made in the RepRap machine back in about 2009 or so, a pair of Charles sandals made from old milk bottles, which we've done through the machine. Now, the nice thing there about Charles sandals, of course, is that children annoyingly have feet that grow, and so you can just chuck the sandals back into the machine, put an extra milk bottle in, and make a bigger pair of sandals when your child grows, his feet grow. Paper, coming back to that, there are machines that work with cellulose, and of course paper is cellulose. So if you were prepared to process the paper into cellulose, then the answer to your question is yes. But as far as I'm aware, no one has made a cellulose processing machine that takes waste paper as an input and produces material for running through the machine as an output. But I can't, thinking about it now, and I haven't really thought about it in depth, but thinking about it now, I can't see any technical reason why that couldn't be done. But I don't think it has to be.
I see. And can I ask another question?
Of course.
Yeah. How do you imagine the world if majority of the population get access to replication device like 3D printers? Like every home has a 3D machine or device.
Well, it depends on the capabilities of the machine. They're getting better all the time, and I should imagine, certainly within my lifetime, though I'm horribly old, so that might not be as long as I might like, but I should imagine within my lifetime we'll be more or less at the point where these machines can do things like printing phones, printing parts of vacuum cleaners, printing refrigerator doors, that sort of thing. And of course, once you're in that position, you're at a very scaled up place, rather like the position the photographic film industry was in about 1995 or 96, when digital cameras started coming in. Suddenly nobody needed industrially produced photographic film anymore, and nobody needed to send off those little yellow envelopes full of film to get your prints back 3 weeks later. An industry just disappeared. Now, you could imagine when people are capable of producing things for themselves, that the industries that produce those things would probably atrophy and people would be doing the work for themselves. An example I always give is the example of laundry. Our great-grandparents and our grandparents used to send their laundry off to the town laundry every week, and the town laundry would launder it, and it would come back a few days later in paper bags, not nicely folded and ironed, possibly. But none of us do that anymore because we've all got a robot in our kitchen to do our laundries. And that robot has a number of interesting characteristics. One, of course, is that it does the laundry and it's very convenient. The second is that we're perfectly happy for it to sit there for 95% of the time doing absolutely nothing at all. We've spent capital on that robot, and yet we're happy for it to be idle and just do the thing we want it to do for a few hours every week. And much the same, I suspect, will happen with 3D printers. People will be happy to have them in a corner of their house and just use them when they want a new coat hook to hang their coat on. The other thing about laundry, of course, is that if the town laundry, suppose the water supply to the town laundry fails, then the entire town doesn't get its laundry washed. Whereas if your washing machine fails, then you can go and knock on your neighbor's door and say, I'm terribly sorry, my washing machine is broken. I don't suppose I could wash my clothes in your town. If they're a friendly neighbor, they'll say yes. So by distributing a technology, you make the world more robust because people are less reliant on a central resource. And similarly, if you're printing your own goods, your own purse, the hinge for the doors in your house, whatever it might be, if you're printing those things and your machine goes wrong, well, first of all, if it's a ret wrap, in principle, it's capable of repairing itself, which is good news because it's you get self-repair for free when you have self-reproduction. But even if your machine is so badly damaged that it can't work at all, you can go to your neighbor and say, can you print me a spare part for my printer? And suddenly you're up and running again. So it's much more robust than centralized facilities. Now, nobody's going to be using these machines to make print container ships anytime soon, I don't think. There's a scale thing here. They're making objects around about the size of, tens of centimeters on the side, that sort of thing. Though there has been a recent introduction of a new designer machine which is capable of printing things which are arbitrarily long in one dimension. So people are already printing beams 6 meters long, for example, to use in construction projects in a machine that's the size of a laptop. The beam just comes out of one end of the imaginary laptop and grows as long as you like, which is great fun. We've just acquired one of these machines ourselves, and we're looking forward to playing around with it. So, and that really illustrates the thing I meant about the capacity of these things expanding all the time. As that capacity expands, more people can make more things with them, including more of the machines themselves.
Actually, I think there's a couple of really interesting similar questions around medicine, Adrian. Anika, you had one around like creating medicine with printing, right? Not sure if you want to add more to it as well.
What's that? Using the machine to print medicines, if you like. Is that really the question?
Yeah. I remember when we would talk a long time ago, first time we talked, you were saying that actual the capacity to use RepRap for print medication would be even much stronger than the capacity of it to print things, because then the people can really, you know.
Yeah, well, yeah. Not print medicine in the machine directly, but one of the things people have done with the machines, and which you can do, is to make basically a chemical synthesis machine. As I'm sure you're all aware, medicines are produced, for example, by bacteria in large vats, usually genetically engineered bacteria, churning out molecules literally by the kilograms every second. But of course, an individual patient doesn't need that much medicine. So what you can do is you can make a little miniature laboratory in the form of a series of small electrically actuated pumps and devices for redirecting fluids and reagents and so on around the internal of the machine, which could make medicines not by the kilogram, but by the milligram. And if you need, I don't know what it might be, 50 milligrams of heart medication every day, then there's no reason why you shouldn't print a machine to make that and then manufacture it for yourself. And once you start doing that, a very interesting aspect of patent law kicks in. And that is this. In Europe, not in America, in Europe, anybody is allowed to make any patented object, and that includes, of course, a patented medicine, which is a patented molecule, if you will. Anybody is allowed to make any patented object for their own use, as long as it's not a commercial activity. So there's nothing to stop you, if you have an appropriate chemical production machine, manufacturing medicines for your own use, even if those medicines are patented. And of course, one of the aspects of a patent is that the patent has to publish what the structure of the object that's, or in this case, the molecule that's patented is. So we all know how these medicines are put together chemically. And so we've got an interesting route there for individuals to circumvent patents on patented medicines, as long as they don't then try to sell the products of that to other people, as long as they restrict their use to themselves. So yeah, the machine can't make medicines, but the machine can make a machine that makes medicines. Now, obviously, to a certain extent, it'll depend on the complexity of the molecule you want to make. Some are tricky, some are straightforward, but in principle, you could do it, and some people have done it with simple chemical reactions.
And then actually, Adrian, you touched upon a point which is similar to another question that Vasily is asking. How much technical capacity or competence do you need, to really get the most out of RepRap as a printer?
Two different levels. If you're just going to use the machines, most people, including quite young children, can usually get the hang of them reasonably quickly and start using them. So in that case, I'd have no problem with an 8 or a 9-year-old using one of these machines. They probably get the hang of it more quickly than an adult, because that's the nature of being an 8 or a 9-year-old. If you want to assemble one of the machines for yourself, then you do need a bit more technical knowledge. Basically, you'd need the sort of level of knowledge that someone 16 or 17 pursuing sciencey and technology type A levels would have. That's the sort of level you'd need probably to put one of these machines together yourself.
Got it. And I think one other question we had, which is somewhat relevant as well, is any privacy concerns around using 3D printing that you're aware of? Or
I'm not sure about privacy concerns. There are all sorts of, I'm going to make quote marks here in an annoying rabbit ear way. There are all sorts of intellectual property implications of these machines, though comparatively few of those, surprisingly few of them, in fact, impinge upon you if you're just using the machines for your own use. That most intellectual property law is worried about people selling stuff, not about people using stuff. So if you want to make a spare part for your car in your machine, then that's fine. I can't really see the problems with privacy. The machines don't monitor anything you do. Mechanically, they're comparatively straightforward. there are lots of public libraries, of course, of designs for people to download. If you can't be bothered to design your own stuff, there are literally millions of designs out there for three-dimensional objects which are free for people to download and build on their machines themselves. Everything from birdhouses to pairs of electronic tweezers, you know. But again, apart from the slight compromise of privacy in that people might know what you've downloaded, I don't see that there are any real implications. Maybe someone can think of something that I haven't thought of, but I don't think so.
Rob asked, what about printing money and credit cards?
That would be difficult with the current level of technology. Just to look at credit cards first. Credit cards, of course, incorporate chips, and those chips are encrypted, and you can't realistically reproduce that. Money, of course, again, banknotes are deliberately made incredibly difficult to forge. They incorporate holograms and heaven knows what else, and they're made of very thin sheets of plastic. So again, quite difficult. But I can tell you a small anecdote about a hacker and maker fair that I went to in Holland, where they had a system where you would buy plastic tokens to get food from the food distributors who were on the site. It was like a big festival, like a big music festival, but it was full of people in tents making things. And basically, when you arrived, you got out 20 euros and you turned it into these plastic tokens, and then you could go and get a sandwich with a plastic token. Of course, everybody with 3D printers on the site started printing these plastic tokens, and one or two of them got to the point where they were indistinguishable from the ones that were being distributed at the front. So conventional money, no, because they make it very hard to forge. But once you start talking about things like casino chips or plastic tokens at maker fairs that are being distributed for people to get sandwiches, then that starts to get a bit easier to do.
And I think, Adrian, I think there's a lot of really great questions, but I think I did want to give like one question around Museum of Care, which I know Nika has been had one on her mind as well. So I think, Nika, you had one around Museum of Care to ask Adrian.
Mm-hmm. Do I have anything to ask? Well, yeah, Nika invited me along, but I apologize to say I've been very, very busy in the last couple of weeks. I haven't actually had a chance to look very much into what you do. So as I say, I apologize for coming so unprepared. Perhaps you could tell me a little bit about precisely what your function and purpose is.
Oh, Nika, you're on mute.
Nika, you're going to have to unmute your microphone.
Mm-hmm. Yeah, I think we're trying to achieve very much the same as you. We're trying to replicate the model that was called in Soviet Union prolet cult, and that's kind of abandonment of art. So the situation when everybody is an artist is more or less a situation where everybody is the proletarian and the owner of the factory at the same time. And in this case, we don't need the market anymore, because the market is the system that have to operate with the concept of scarcity. So if there is no scarcity, there is no market. You just don't exist. So that's like a perfect way of killing the market, or just eliminating the market if you have everything is too much or enough.
Yeah. Okay. Yes, I understand. One of the things I like to do is to compose music. My difficulty there is I'm completely incompetent at playing music. I can just about play a chord on a piano or an electronic keyboard. I can just about get a chord out of a guitar, but I have no mechanical faculty for music, though I have music playing in my head whenever I want it to happen. It's all in there. I just can't get it out. But of course, one of the things that modern computer composition software allows you to do is to completely bypass technical limitations you might have in playing music. I can literally plonk semi-breathes, breathes and quavers down on a musical score and have the machine play it to me on a harpsichord or whatever. And that works fine. Now, 3D printing is a little bit like that because, of course, it turns everybody into a sculptor. Even if you don't have the facility to carve a piece of wood or a piece of marble, if you've got the concept for a three-dimensional object that you wish to create, and you're prepared to spend the time on a computer creating a virtual version of that object, then the machine will print it for you. And moving perhaps from 3 dimensions to 2, one of the things the machines are fairly easy to adapt to do is actually to turn them into a painting robot. One of the things I did when I was still an academic was to get a couple of students for a project to take one of these machines and to equip it with a series of pots of paint and some paintbrushes instead of its normal plastic producing head. And basically they programmed it to go and dip the paintbrush into the paint pots and paint pictures. And this worked rather nicely, in fact. And so as far as the production of works of art are concerned, there are all sorts of technologies around that allow, as you say, a large number of people to produce such things without, even when all you need is the concept, you don't necessarily have to have the technical ability to do it, as long as you have the patience to master the computer and get the computer to do it for you. And that's expanding out, I think, into all sorts of different areas of art. And that seems to me to be a completely good thing, because plenty of people have ideas for songs or ideas, as I say, for sculpture or paintings or whatever it might be. And yet only a subset of those people have the technical ability to produce those things using the conventional instruments that musicians and artists and painters and so on would use. But the computer will mediate that. As long as you have the patience to take time on the computer, you can keep correcting your mistakes and keep editing everything until it comes out right. So it's a technology.
Adrian, so I don't know how, Nika asked to explain the project. So more or less, I don't know how much this is clear now, but we would be like a network, an international network of spaces that are free from the market, free from capitalism. So like we will have.
Can you make them free from the market? I mean, here we are. Sorry, I've interrupted you, and I do apologize, but can you really make them completely free from the market, given that we're all sitting here talking on computers made by commercial companies?
Well, I think the most important thing is like to be as autonomous as we can,
right?
Even
okay.
if we,
yeah.
And yes, so we had this idea that we don't want to be like some sort of individualistic Airbnb art thing, a system, a network of art residencies. We want to be, really collective thing. So we were thinking about having projects that can circulate in our network and be replicated and create a community.
Yeah.
So we were thinking, I think that's what we were thinking, to have your project also more or less involved in this, right?
Yeah.
So that's all I understood now, Nika. I think that's you.
Well, yes, I mean, as it were, you can do that without. I wouldn't presume to think that you might need my permission, but of course, because it's open source, you can do what you like with it. Now, I should perhaps explain a little bit about my position with respect to the RepRap project. I'm nominally running it, except ever since it started, I haven't really run it. I've just let it go in whatever direction it wants to go in. And plenty of people have taken it and done things which I've been surprised. Oh, you've made a machine. Oh, that's interesting. I haven't seen that before. So there's nothing to stop you adopting it, and I'd be happy to endorse your doing so, and I'd be happy to help where I can. But though I'm responsible for the RepRap project, I suppose, it runs itself, and it more or less always has done, because enough people have been interested and involved to take it in all the many different directions that they want to take it in. And you could do exactly the same with it if you wish.
Adrian, you can presumably make instruments of torture with it. You can make weapons to kill people and things.
Well, weapons is an interesting one, because people have made 3D printed guns, which of course, given that they're made of plastic, represent a considerably greater danger to the manufacturer than to the target. But people tend not to know this, but if you wanted to make a weapon, the gun is the obvious weapon to consider. If you want to make a weapon, 3D printer is probably just about the worst technology to choose to do it. I don't normally give advice to people how to make weapons, but I'm pretty sure that I can tell this group something which will go no further. If you want to make a weapon, what you do is you go down to your local branch of B&Q and you buy a Black & Decker pillar drill, you buy an angle grinder, and you buy a welder. That'll cost you less than a 3D printer will cost you. And it's all the tools you need to make a Sten gun. And the Sten gun has been around as a design in the public domain since the Second World War, when its design was widely distributed to resistance groups by the British government. And that's a genie that won't go back in the bottle. One of the interesting things about technology is that even though technically it's pretty simple to make Sten guns, given the 3 tools which I've just described, which are pretty much universally available, we don't have a big Sten gun problem anywhere in the world. And people don't seem to choose to do this very much, which I think is a jolly good thing, and perhaps is a hopeful indication that human beings are not quite as horrible as we might sometimes be led to believe. But as with all manufacturing technology, rep machines, 3D printers in general, can be turned to making pretty much anything. And what those things are is dependent upon what design is downloaded to put into them.
So I think just being mindful of time, maybe we go for 10 more minutes. I think this is great. I mean, it speaks to how interesting all this is, Adrian. Like, I think the questions keep coming. I think we'll keep discussing. So I think Phoebe had one question, which I think is quite worth discussing also. It's so, you know, like Anat Singh, who's like a famous anthropologist and theorist as well. She has this idea of the plantation, which how she uses it to think through how capitalism creates machines of replication, which are producing assets ultimately, you know. So in a similar way, I guess, like with something like 3D printers, what are the relationships that 3D printers have with, you know, like other species and the environments that their materials come from, you know? And Phoebe, like, please let me know if I asked that question right, or if you have anything to add, please feel free to.
I've gone quiet to let her speak.
Sorry, I was just going to say, yeah, that no, you summed that up perfectly. Do continue.
Well, the whole RepRap project was biomimetic. I said that it was prompted by my interest right from childhood in self-replicating machines. And of course, that interest stems from an interest in biology. I'm an engineer, but every engineer is a biologist monkey, because we look at the natural world and there are so many wonderful machines in it that, and also terrible ones, incidentally, that if you look at evolved systems and evolved machinery, every engineer just wants to get in there and say, no, don't do it that way, do it this way, that's crazy. It's the nature of Darwinian evolution that it produces solutions that are good enough, not solutions that are necessarily all that elegant. But the big thing about nature, by which I mean biology, is that biology is the study of things that copy themselves. And that's where my interest in self-copying artificial machines came from. And of course, it's more than just a self-copying machine. When I started the project, I wanted to make something that was going to be successful in Darwinian terms. And so it seemed to me that if you're going to make something that's self-replicating, then it has to have a relationship with all the other self-replicators that are around, which is to say all the living organisms in the natural world, and in particular, and one in particular, of course, which is human beings. So I tried to make the machine so that it was in a symbiotic relationship with human beings. Symbiotic is not quite the right word from the biologically technical standpoint. Biologists call it mutualist symbolism. I can't say symbioticism. Yes, I can. I just did. Mutualist symbioticism. The good example of this is the relationship between the flowering plants and the pollinating insects, which goes right back to the late Jurassic. That's a symbiosis that's gone from strength to strength ever since it first evolved. And of course, we all know how it works. The plants can't move, but they need to get their pollen to another plant. The insects can move, but they have no interest in plants unless the plants produce a bribe. The plants produce the bribe in the form of nectar. The insects then visit the plant to get the nectar and inadvertently transfer the pollen to another plant. So the plant gets what it wants, the insect gets a meal, everybody's reasonably happy. I deliberately designed RepRap to work in the same way with human beings. The human beings take the position of the insects. The human beings are needed to assemble the machine. In other words, we're needed to help the machine to reproduce. The machine itself takes the position of the plants. It's the thing that wants to reproduce. Well, of course, no machine wants anything, but you understand what I mean. The machine wants to reproduce, but it can't entirely do that itself because it needs something to put it together. So the human being puts it together, the machine wants to reproduce but can't be put together. What's there to give the human being an incentive to assist the machine to reproduce itself? The answer is the goods the machine produces when it's not making copies of itself, and those are the equivalent to the nectar that the plants produce to attract the insects. And I deliberately tried to copy that symbiosis when I started the project. I had it in mind from before I even really thought about using 3D printing to do a self-copying machine. And the reason I tried to do that is because I knew it was a stable relationship. You don't last from the Jurassic age to the present day without being stable. And as I say, that's what the relationship between flowering plants and insects has been. So we've got that sort of biological parallel there. I don't quite know if that answers your question or not, but it's sort of an attempt to do so.
No, thank you. And that gave me lots of food for thought.
Great. So I think we are very close to time, I think, but I think, again, it speaks to just how cool RepRap is that we're getting so many questions, Adrian. So I think, it's just been really interesting and like great discussion for all of us all around. I'm just curious, like, is there a way we can reach out to you if any of us have questions?
Nico, feel free to share my email address with everybody. I'd be perfectly happy for you to do that. And anybody, feel free to email me. Or if you lose my email address, if you just Google my name, you'll find my website, and I've got a contact page on my website. Feel free to send me anything you want to ask.
Mm-hmm. Yeah, but I just want to say that we will try to introduce a 3D printer in our project that will start on the same day as was Carnival for David this year. It will be on 11th of October 2021, and we will try to find people who are already working with RepRap and connect to them and introduce them to our project Visual Assembly. But also maybe we can try to collect the money to put together a couple of some 3D printers and send them to places as Rojava or Chiapas, Zapatista, or places like that who may not have them yet, but for them specifically, that will be a very good technology to be introduced to. And partly, as I read in your manifesto, an original one that was designed for the people not in who's living in the golden billions in the West, but specifically to the other human beings who don't have the factors. Yeah. But thank you so much for coming. That was amazing, and we hope we can just develop this collaboration with RepRap.
Yes, I hope so too. Thank you very much for inviting me. It's been a great pleasure. I'm an ex-academic, so I never tire of the sound of my own voice.
That's great. And to everyone else, I think thanks again for joining, and hope this has been fun. So what you can look forward to next time is we'll be discussing Nika and David's essay on another art world. I think it actually ties in well with our discussion today on RepRap. I know Nika mentioned Prolet Code once. So yeah, I think we'll see you very shortly at our next assembly. And yeah, with that, yeah, we'll come in soon. Thanks so much, everyone.
Thank you.
Bye-bye.